Hey, what's up, guys? Chong here again. So this time I want to talk about this very interesting interactive problem here. Number 400, sorry, number 843. Guess the word. Okay. So you're given like a word of list of unique words. Each of word is 6 letters long, and among all those words, one of them is chosen to be the secret word. And then you're given an interface here where you can pass in a word with length of 6, and then and it will tells you how many digits, the number of digits are exactly matching with the secret word. And if your guess is not in the given word list, it will return -1 instead. Okay, so for each of the test case, you have 10 guesses to guess the word. At the end of any number of calls, if you made 10 or less calls, and to, to get to guess the correct secret word, then it pass. And so the test range, the test case is of around 100 words, right? And each word only consists of from a random number from A to Z, right? Lowercase. So for example, this one here. So the secret word is ACCKZZ, and you make this call guess, and it tells you -1, right? And if you happen to guess the correct word, right, and then 6, which means okay, we got the final answer. If it's CCBAZZ, it returns 3. So, oh, I'm gonna see, see I'm gonna draw it here. So if it's A C C K Z Z and it's C C B A Z Z, right? So this is the secret. This is a guess. Okay. So here, this one, 2, and 3. All right. That's how you get 3 here from this guess interface here. So how can you approach this solution, right? It's a very interesting problem here. So um, basically 2 steps. Let's think about the first step. Assuming we have this 3 here, right? So let's assuming we have this either 3 or 2 or whichever matches we need, right? But as long as it's not 6, then we know we need to keep searching, right? Or keep guessing. So if we have 2 here, once we have the number 2 here, what what can we do about this, right? So what we can do, so if we have 2 here and we have this EIOWZZ, we can use this number 2 and this guess word to eliminate some of the candidates, right? How, right? Think about this way. So if we have this number 2, the match is number 2 and the guess word is this one. So it tells us uh, all the candidates has to be exactly, I mean, has to have the same pair matches with this one, with number 2. All right. So basically, once we have this 2 here, we loop through all the candidates, right? We loop through all the candidates, and for each of the candidates, we compare this one with the word with our guess word, and then we'll calculate what's the exact matches between those 2 words. If the matrix does not equals to 2, then we know this number, this word can't be the secret, right? Why? Because let's say this one has like matrix 2, right? And let's say we loop through any word, and between this one and this word, let's say the difference, the matrix, the matching characters is 1. Let's say it's 1, and we are how do we prove it, right? Let's assuming if this character, if this word is is a secret word, right? If that's the case, when we pass this like guess word to compare with the secret word, instead of 2, we will get 1, right? Same thing, same for the for 3, right? Basically, we can just use this like contradiction to prove any of the candidates has to have the exactly the same matching numbers as this number here. Okay, so that's the first step. Every time when we have a matching numbers here, we can go back to loop through all the candidates. We can filter some of the candidates away, right? So that's the first step. And now the second question will be, how can we choose this guess word, right? See, I think it seem quite obvious if we cannot just do a random pick around all those words, right? So because that would be too random, most likely we won't be finished. We won't be find the filter out all the invalid candidates within 10 guesses, right? So how should we, what strategy we should use to pick the guess word here, right? So if you watch it closely, I think we should use the most common one. What the most common one means, I mean the word that can represent most of the candidates, right? So we need to find like the most common words in another word, right? To make the guess among the current candidates. So how can we calculate? How can we know, right? How can we know which word I mean is the most common one, right? So what we can do here is we can have like for each of the we can create the 2D array here. Basically, for each of the positions here, basically we're gonna have like a two bucket here, right? Can have like 1, 2, 3, 4, 5, 6, right? So this is like represents the strings from uh 0 to 5. That's the length of the string. And on each of the bucket here, we're gonna uh, have another like array, basically a 2D array here. So here it's gonna be a like uh, an index of 26. All right. Basically, this 2D array tells us at this position 0 or like at position I, uh, how many uh, the frequency, basically the count for this character, right? And when we have this one, so basically the first loop is going to be we're going to loop through all the candidates, and for each candidate we're going to loop through each characters, and then we just increase the count of each positions here. In the end, we have this 2D arrays tells us at at each positions which each characters the frequency of each character. And once we have that, right, then we do a second loop to loop through the candidates one more time, and this time we will basically have a scoring system. Basically, every time when we see some characters here, we will get the count from the current position, and we'll use that count. We're gonna summarize the count as the current score. So who basically which word has the highest score will be the most common words, right, among all the candidates right now, and we're gonna use that word to make the guess. Make sense? And um, Okay, cool. So I hope hopefully this make kind of make sense to you guys. And let's try to do the coding here. So let's see. So we're gonna have, like I said, we're gonna have two helper functions, right? Basically, the first one is gonna be a mm, we can call it a match count, right? A match count between between the two strings, right? And then the second one is gonna be the how to find the most common get uh, most most common word, okay? So and then we're gonna have a candidates, right? We're gonna have a candidates array here. So as the initial, since we're going to keep eliminating these candidates, right? So and when we're calculating the counts and the get most uh, uh, yeah, I think we can just use these words here since we're not going to use it anymore. I mean, as long as it allows us to modify it, I think it's fine. Yeah, we don't. I think we can just remove these candidates here. Basically, every time, right? While there's still something in this word list, okay? And then we do what? We find the word, right? The word equals to what? Get most common word, right? We'll implement those two helper functions later, but now let's finish our main uh, logic here. So every time when we have the most common word here, right? We do what? We do a guess, right? We do a match. We do a match, right? So we do a master dot guess, right? With this word here, right? And then we do what? We remove, once we have this match here, we will remove the anything that doesn't have the same match, right? So actually we need a maybe we need three helper functions, but okay, so let's do a three helper functions. Uh, you know what? Invalid word. Okay, yeah, you know what? Actually, I'm gonna do this. So remove invalid word. Okay, so here we basically check if match, right, equals to 6, right? Then we simply return. Okay, so basically that's the two uh, and then it's time for us to implement this like two helper functions, right? So the first one is once we have the match here, we're gonna remove the invalid words. How, right? Let's do a basically we since we have the word and we have the it's gonna be a guess word. I'm gonna call it guess word, okay? We have the guess word and we have the match, right? Then we can just loop through the current word list, okay? And yeah, so we're gonna remove it from that. Let's see. Yeah, let's just do a remove here. We can have some other ways of doing it, but let's say for word in word list, right? Well, actually, no, actually, I cannot do it because I don't want I cannot do the while loop for loop while modifying the loop itself, the iterator itself, right? So we need to have like a temp file here. So it's gonna be a filtered filtered list, okay? And then so okay, okay, fine. I'm gonna create a candidate here. Word list. Okay. I think it's fine to call it candidate here. So and every time we just do a you know what? Fine, fine. Here I'm gonna in the end I'm once we remove it, so this helper function is gonna return like updated list, right, to this word list, so it can keep looping through it, right? And filter the list. Mm, okay, we need let's create a third helper function here. Basically, this one is gonna give us the pair matches, right, between A and B. So this is pretty simple. We just return the the match numbers, the match strings for both from A and B. You can do like a shortcut here. Basically, we summarize if the C1 equals to C2, right? For C1 and C2 in zip, right? We can just zip this A and B together, right? And then if it's the same, then it's one, right? And we summarize it, then we'll have the count. And then here, basically, if the uh, every pair matches, right, for the guess word and the current word is equal to the match, right? And then we do a filtered list dot append, right? And in the end, we simply return this filtered list, okay? Right? Because this will also filter out this guess word itself, right? Because notice here, because if for the same word, this match will always be six, right? But at this time, the match is not six. It's not six. That's why this guess word itself will also be removed during this process. And then here is the second one, right? So this is the second main helper functions. How can we get the most common word, right? So like I said, we're gonna have a count here, right? It's gonna be a 2D arrays here. The first is the six, right? That's index. Sorry, the second is the 26 for all the uh, letters, and the first one is gonna be six, right? So and for the first in word list, right? That's the current word list, right? We do what? We do for I equals to C, right? And in word, right? So we do a count. The first one is the index, and the second one we do what? We simply do a word. We do a current C minus A, right? So that can give us like a relative positions of that's how we do a count, mark each of the characters, right? We from the current one to the minus k, we can map this character into the zero-based zero-based index here, right? Do a plus one, right? Now we have, since we have that, now we let's do here we're gonna have like a best score and zero and the best word, right? Equals to empty. We're gonna keep this two variables here, right? So we're gonna list it one more time here, and for I, C in W, right? Current score, okay? So current score plus what? So it's gonna be counts, right? So the current I, same thing, right? Basic here. That's how we current do the current calculate the current score. And if the current score is greater than the best score, right? We simply do a best score equals to current score, and the best word will be the current word. In the end, we simply return the best word. Okay, so I think that's it is. Let's see if we can get the most defined word. Okay, not enough values. Oh, sorry. Enumerate. Uh, enumerate. Same for here. Built-in function is not a subscribe. Okay, sorry. Okay. So many typos. Sorry. I think this I didn't do too much preparation for this one. Ah, same. Okay. Okay. Come on. Ah. Okay. Finally, at least the first test case passed. Let's try to submit it. Whew. Okay. Passed. All right. Nice. So recap real quick, right? So first thing first. Once we have the match numbers, we have to find a way to remove the invalid word, right? The way we're removing it is to use this current match to compare with everything in the current candidates list. Anything that does not have the exact match, right, with the current matching count will be removed from the candidates list. And second one would be how can we find the guess word, the guess word here, right? Basically, we count all the frequencies appeared on each of the positions, and then we're using a scoring system here to calculate which word has the highest score, right? Then that word will be our most common word, and then we use that word to keep doing the guessing here until we find the sixth. Uh, cool. I think that's pretty much it is for this problem. Very interesting problem. Yeah, and it's a hard one. Yeah. Uh, I hope you guys enjoyed the videos. Thank you so much for watching it, and I'll be seeing you guys soon. Bye bye.